Hydrogen fuel cell vehicles. Hydrogen fuel cell vehicles, FCVs, are a type of environmentally friendly transportation that use hydrogen gas as their primary fuel source. They operate by converting hydrogen and oxygen into electricity, which then powers an electric motor to propel the vehicle. The only byproduct of this process is water vapor, making FCVs a promising alternative to conventional gasoline-powered vehicles, as they produce no harmful emissions. The main components of a hydrogen fuel cell vehicle include 1. Hydrogen tanks. These store compressed hydrogen gas on board the vehicle. The tanks are designed to ensure safety and efficiency in storing and releasing the hydrogen. 2. Fuel cell stack. The fuel cell stack contains multiple fuel cells that consist of an anode and a cathode separated by an electrolyte. During operation, hydrogen gas is supplied to the anode, while oxygen, usually from the air, is supplied to the cathode. The hydrogen molecules split into protons and electrons at the anode, and the protons pass through the electrolyte to the cathode, while the electrons flow through an external circuit, creating an electric current. 3. Electric motor. The electric current generated by the fuel cell stack powers the electric motor, which drives the vehicle's wheels. This electric motor is responsible for converting the electrical energy into mechanical energy, propelling the vehicle forward. 4. Battery. In some hydrogen fuel cell vehicles, a small battery is included to store excess electricity generated by the fuel cell stack. This allows for more efficient energy management, as the battery can be used during periods of high power demand or to store energy during regenerative braking. Advantages of hydrogen fuel cell vehicles. 1. Zero emissions. The only byproduct of hydrogen fuel cells is water vapor, making FCVs a clean and environmentally friendly option for reducing greenhouse gas emissions and air pollution. 2. High energy density. Hydrogen has a higher energy density than conventional batteries, providing longer driving ranges and quicker refueling times compared to electric vehicles that solely rely on batteries. 3. Fast refueling. Hydrogen refueling typically takes only a few minutes, similar to refueling a conventional gasoline-powered car, which makes FCVs more convenient for long trips. Challenges and limitations. 1. Hydrogen infrastructure. The main challenge for the widespread adoption of FCVs is the limited infrastructure for producing, transporting, and dispensing hydrogen fuel. Establishing a reliable and accessible hydrogen refueling network is crucial for their success. 2. Production costs. Currently, producing hydrogen through renewable methods is expensive, which affects the overall cost of fuel cell vehicles. Finding cost-effective and sustainable production methods is essential for making FCVs more competitive in the market. 3. Energy efficiency. While hydrogen fuel cell vehicles are efficient in converting hydrogen into electricity, there are energy losses in the overall hydrogen production, transportation, and conversion process, which affects their overall energy efficiency. In conclusion, hydrogen fuel cell vehicles offer great potential as a sustainable and zero-emission transportation solution, but they face challenges that need to be addressed to realize their widespread adoption. As technology advances and infrastructure improves, these vehicles could play a significant role in a greener and more sustainable future for transportation.